Welcome to the panel on startup panel on 5G. So we have 4 brave souls there who have ventured into the world of startups in the 5G space. I will make a quick introduction to each and every one of them, and then we will follow that up with a bunch of questions. I will follow that up with a bunch of questions, and hopefully we will have time to open it up. By the way, I'm Nambi Seshadri. I'm a professor here at the ECE department. The 4 panelists are Reza, Rofougaran. Reza is founder and CTO of Movandi Networks, company focused on RF solutions, and he will explain more in the 5G space. And Jim Maines is actually CEO and founder of Shoelace Wireless. Jim actually is a veteran of the, very quickly, Reza is actually, has had a is a pioneer in the RF CMOS space, very illustrious career, probably on track to beat 1,000 patents. When he left Broadcom, I think he had well over 700. Now it's probably well over 800 patents issued. And he's a member of National Academy of Engineering, fellow of IEEE. So put billions of RF chips into production. So, really a pioneer in the space. Jim Maines is a multi-decade veteran of the telecom industry. And his passion is connectivity, really making sure that everyone is connected. So his startup is focused on essentially figuring out how do we essentially use all the multiple modalities of communication we have, Wi-Fi, fixed wireless, wireline, whatever it may be, broadband into the home, to essentially manage connectivity, both within enterprises as well as in the phones, as well as in the homes. Ketan Kamdar, you want me to be here? Okay. Turn this off. Yeah. So Ketan Kamdar is, let me actually, before Ketan, Sirish Raghuram is CEO and founder of Platform 9, company focused on distributed cloud services, which is his passion. And he is going to explain how distributed cloud services and 5G are going to come together. Sirish is one of the early engineers of VMware and developed many products before starting Platform 9. Ketan Kamdar is also another veteran of the wireless industry. He was he had seen both sides, the service provider side of cellular as well as the semiconductor side of cellular. Long-term veteran of AT&T, followed by Broadcom. And he is actually one of the founders of Geoverse company, essentially trying to be a service provider, making use of CBRS spectrum and hopefully over time, other shared spectrum in the 5G space and so on. So he is going to talk about, what's, how we can be a startup and be a service provider as well. So with that, I will actually ask them to give a quick 2-minute introduction to their companies. Reza, why don't you start off talking about what your company does, what are the product offering, and why 5G?
Yeah.
How did you decide to get?
Can I share something? I have some slide. I don't know if I can share it or not, but if I can share, I can bring this slide up.
You can.
I can? Okay, so let me see, how do I share it then? Share the screen, okay. Okay. You see it now?
Yeah, Reza, just use a couple of 2 to 3 minutes, not much more than that.
Can you see it? Can you see this?
Yes.
Okay. Yeah, I'm a founder of the Movandi Corporation, and we focus on 5G, mostly on the front end, but we also have a system solution that I explain quickly. What we do is we basically introduce an element called relay, which is basically a node between the G node B and your mobile devices or the end devices. And the job of these relays is basically link the G-node Bs to and provide indirect beam to UE devices. So you can actually have these relay distributed in the city and or in indoor, and basically connect them in a mesh together. And you can actually remotely define the beam characteristics, beam narrow beam or wide beam, or change the beam based on dynamically based on the changes on an environment, and be able to basically route the beam from the source, which is G-node B, all the way to end user. So what we do is basically make sure that the connection between G-node B and the end user always exists through these mesh of these relays. And this is basically mostly for millimeter wave, because a lot of time, you know, the millimeter wave signal are blocked or basically need to amplify to get back to the level that you can actually achieve the capacity or data rate that you want to deliver to UE. And that's what we do. So in order to do that, we actually have to address the mobility, and the mobility, the way we does is basically the UE and the relay are managed through the cloud. So we make sure that the beam that gets to any devices are managed through the cloud by knowing the position of the G-node B and the relay in the fields, and be able to actually hand off between these nodes. And this is done through the cloud management and Movandi has. So the relay within the, and there are two types of the relay that are a fixed position, which basically distribute the beams. And we call those relay as part of software defined beam networking. Basically they set up the beam between the nodes and mesh them together to deliver the signal to the end user. And then there's a relay that associated with the end user, which is the relay in the car or relay that goes as a portable with your phone. And the job of those relay is to make sure that you receive enough power for the rate that you want to achieve. And then these relay basically capture a good amount of signal to noise ratio and then provide it to your UE, so you can get over 1 gigabit per second no matter where you're driving. So you will never lose the connection from millimeter wave as long as there are G-node B around, and you will not go to LTE. So there is no fallback. There's always remain in the original connection of that you have. And then if you look at if you go back on the one slide, my slide, sorry, yeah. And I have one quick video that shows some of the work that we have done, and maybe I can show this one if I can share it. Let me see if I is it showing or no? Let me see.
Not yet, Reza, but
maybe we can do it later. Yeah. Okay. So that's yeah.
Come back.
Yeah.
Come back later. Yeah.
Sure. Yeah. Right.
Do you want to say a little bit about what Shoelace Wireless offering us?
Okay, sure. So are you talking to me or am I done?
That was Jim Mains.
Okay, sure.
Sure. Thanks, Nambi, and thanks to UCSD for hosting this event. It's pretty exciting. It's been listening all day. Shoelace is a startup focusing on optimizing spectrum using cooperative networking technologies, focusing on convergence. Willie talked a little bit about some of the importance of heterogeneous networks and convergence and that. So we actually made this practical by able to port it on a mobile device and leverage all spectrum, whether it's licensed and unlicensed. And recently we ported that to gateway technology, so it can run on a home gateway, which is important because, as you know, operators are struggling with monetizing 5G on the mobile phone. Users aren't buying or paying more for a 5G plan on their phone. And so what we address is both a cost saving side of perspective and revenue generation. From the costs, by leveraging licensed and unlicensed spectrum. And everybody in that room and pretty much all of us in most of the developed world, 80% of the time you have your mobile network available or you're using it, there's unlicensed spectrum around, Wi-Fi primarily. And so we can intelligently steer that traffic based on quality experience and advanced policies to make sure you're safely connected and have an always best connected experience and save the carriers literally hundreds of millions of dollars a year. And from the revenue perspective, although they can't monetize or have trouble monetizing 5G, but from some of the work we're doing with some leading operators to be able to offer fixed wireless services for since the pandemic has us in a remote working or work at home mode, we've always experienced trouble with connectivity where you have stalled. So it turns out that customers are actually willing to pay for that, or enterprise on behalf of their customers. So by moving our technology onto a converged gateway, compared to traditional, say, multipath technologies, we can very affordably be able to steer that and load balance that traffic and actually create new revenue streams. So essentially what we do is focus on, if you're familiar with 3GPP ATSSS, we basically have mobility and convergence on any multi-rat device. That's it.
Very good. Sirish, you want to say what your company is doing in the space?
Absolutely. So folks, firstly, thank you for having us. It's a pleasure to be here. If I can walk you through a very quick short set of slides. We make it easy to run open distributed clouds, where that's our mission, is to bring the power that people can experience with the public cloud, like the Amazons and the Azures and the Googles of the world, but to make that more widely available and ubiquitous and pervasive for people to use on their choice of infrastructure. And specifically, the rollout of 5G networks and private 5G networks requires compute infrastructure that's distributed, but they need to be operated using modern cloud technologies like containers. And that's where our relevance comes in. So very quickly, the problem that we solve is that if you look at what it takes to refresh a 4G network to run on 5G, or to deploy like private wireless networks, it ultimately requires running multiple cloud sites to support the core or the radio. And that's where container-based network functions are going to be running to support the core and the radio. But today, operators face these problems where deploying each of these sites is painful. From the time when you have hardware up and running to the point you can get a cloud-like dial tone, a cloud-like API, to provision network functions effectively and to operate those on an ongoing basis, the operational complexity is very high. In contrast, if you go to the public cloud, if you go to an Amazon or Azure, you get a dial tone for computing and you can just consume it. So it's much simpler, it's much easier, it's much faster. And so this is where we come in, where we're providing an alternative to the two limited choices that exist today. The choices that people have faced historically is they can go to the public cloud, but in the public cloud, it works in a small number of centralized data centers that the hyperscalers own. And both because of laws of physics, the fact that radio sites need to be distributed, core sites need to be distributed, and laws of economics, right? Like these network operators have just spent 15, 20 years trying to disaggregate and open up the stack, and they're very concerned about going and putting that into the public cloud. They end up dealing with alternatives, and the alternative is to cobble together your own stack, what we call DIY. And it's extremely time-consuming and challenging. This is where we come in. We provide a third option that essentially delivers the speed and the power of the public cloud with the flexibility that you get by doing this yourselves. That's what we do. And this is what we call the open distributed cloud.
Fantastic. So now let's turn to Ketan. Thank you. Ketan, tell us what Geoverse is up to.
Sure. First of all, thanks, Nambi, and thanks, UCSD, for hosting this forum. Appreciate the time. Geoverse is slightly different, as Nambi said, right? We're a wireless carrier that is focused exclusively on the enterprise. And some of you may ask, why start a wireless carrier right now when the market is so saturated and the tier ones are snatching customers from each other and there is no growth, right? But there's a unique problem that exists, which is that we're all familiar with, which is coverage indoors, right? And it is only accentuated further by the fact that 5G, which is getting deployed in the mid-band spectrum, will be deployed first on towers which were built for 800 megahertz and 1900 megahertz and 2100 megahertz. And so 5G is not going to be able to penetrate through those walls, right? And so you're gonna have to build 5G from the inside out, right? So the thesis here is that we will be an enterprise-focused cellular carrier, and we will build private networks, both 5G and 4G, and also be a neutral host network provider for the wireless carriers. So we will own the radio infrastructure, we will own the core network, and we will have the 3 or 4 or 5 wireless carriers as they merge connect through our infrastructure and share the radio access network, right? And that's really the thesis for the existence of Geoverse. What really enabled us to exist is something that the wireless industry has never seen before, right? Where the FCC made available the CBRS spectrum to anybody and everybody for free, essentially, right? Anybody in that room can start a wireless company using the CBRS band. And essentially what we're doing is we're leveraging the CBRS spectrum, but only using it, or mostly using it indoors to enable coverage inside buildings and factories and warehouses and multiple dwelling units and the like. And that's our focus. We will never be a B2C player. Our focus is going to be completely on the enterprise and sell only to that domain. So that's what Geoverse is all about. I can share a little bit more details on what we do as we go through this forum.
Okay, excellent. So why don't we, now that we have heard a little bit about what each of you have done, why don't we move on to you sharing your experiences in dealing with this ecosystem, whether from a funding perspective, customer traction. Startups usually have challenges. You may have to pivot your models, business models, or sometimes even technologies that you're developing and so on. So again, why don't we go through each and every one of you, and maybe you can say a little bit about, how easy it has been for you or difficult it has been for you. So Reza, why don't we start with you on this?
The challenges are that the Movandi had was basically we focus on area of the millimeter wave because there was a lot of challenges to address, and we took an approach of coming up with a lot of solution for making the millimeter wave communication happen. So we took, you saw we took a very aggressive approach of introducing these relay and coming up with the completely a new idea. So part of it is because we introducing a new idea, it was hard to basically penetrate right away to big companies, especially when bigger company are selling their base station, small cell and G-Node B, and they have a story of how they cover issues indoor, outdoor, and also private networking, or in general outdoor networking. And then we had to educate a lot of this carrier that even if you have all of those, there's still issue because what 5G is capable of is wireless, being a wireless fiber. So you actually can deliver over a gigabit per second to UE devices. And if you deliver it in a right and efficient way, not only you help the capacity of the system, increase drastically because now you're capable of delivering much higher signal to end user, like the same thing that Wi-Fi is doing, but also you are capable of reducing the number of the base station because you don't need to design it over capacity. So you can actually design it for the right capacity and be able to scale in future with the, if you need it, so you add more. In addition, basically you can do load balancing between the areas that the traffic is less and the area that the traffic become more. So dynamically, you can actually assign some of these G-Node B, more G-Node B to some location and where the traffic is high. And you can also rebalance the traffic and, be able to utilize the excess capacities from one location to another. And that's what basically our relay network supposed to do. And the relay net doesn't need a fiber, it only needs the power to get connected. And you basically through cloud, you manage all this relay configuration, and you can add a lot of learning and intelligence on the cloud based on the activity and sensing that you get from the surrounding. So to be able to get to this point, it took us a lot of marketing and also educating the end user, like telecom companies, because the ODM or the guys who were basically making system were not helping on that. So that was one challenging. And then the idea of selling, basically coming up with the money. Also, you have to sell it this idea to the investor. So the investor has to understand what you're doing. So that's what also part of the challenge we had. The other part of the challenge about IP, we never had any IP issue because we generate IP every day. So far, we had almost close to 100 patents in Movandi, and I think by end of next year, we may have even double of that. So in next few years, I think Movandi will have come 300. I mean, there are a lot of stuff is so new that when we file patent, is actually granted within 6 months or a year. So we never had any issue with that patent, and there was not a lot of work have been done in this area. So I haven't seen similar work or very limited in the area. So we never had any issue on that regard. So those are and then on challenge also getting the people involved with the companies, hiring people now in this environment that everybody is doing good, big company are hiring people with a good compensation. Now you have to motivate the people based on what you're doing and what their contribution to future is. So that's another challenge we had.
Reza, let me just, since I know a little bit more about your company, I'm going to ask maybe a pointed question for you. I think correct me if I'm wrong, you started off as a millimeter wave RF company. However, you have to go and build relays. Is that correct, that the transition to relay was something that you did not anticipate in the beginning? Is that correct?
Yeah, I think at the beginning we started with purely RF, and but just being RF company, it's hard to maintain your leadership because not having a modem will be an issue. So we were also debating how to address that portion of it. But then when we get involved more with the customer, we realize that there is a missing link between the base station or small cell and UE, because UE doesn't have enough space to capture power. Most of the phones that you have only have a limited area to capture power. So right away it came to my mind that if you have something like a device that has much better area of the capture of power, like your portable charger, you can think about a portable relay. So you can capture much higher signal. So, and then you can actually deliver, because it's a short distance with your UE, you can deliver that good amount of signal to noise ratio to your UE, and then you can actually achieve very high data rate. And that they proved it. And then we also help a lot of the battery life of the UE. So right there, we figure out that if we have a relay which act, be a accessory to your UE, or it can be also act like an access point, Wi-Fi, almost like a Wi-Fi access point that can be within 10 to 20 or 30 meters away from you and deliver a good amount of signal power to you. So you can achieve very high data rate. So there we just realized that, now we can focus on the relay. And then on the relay, we had to do a lot of work because it's not just the amplify and at the same time, we also have to run a lot of intelligence or command on the cloud. So from the back plane, we control all these relays. So from the cloud, over time, we gather the information that the movement of the devices, and then we know exactly how to mesh these relays together. Or if you're using it in the car, we will know exactly later on, we know as you're driving, where are the G node Bs based on the location, and also based on the 3D image radar we have, we know exactly basically how the beam should look like and when you switch the beam. So we don't even let any device, UE does the switching. We do all the switching, and we all provide a good amount of signal to noise ratio to the UE, so the UE will always be connected. So then we start building the software and also some kind of processor that which is part of our relay to basically control, to be able to control all these functions. So the fixed relays are mostly for routing. I call it software-defined beam networking. So you build any beam networking and any radiation pattern that you want to generate for connecting these nodes together. At the same time, also radiation pattern to deliver to the end user or UE. And then portable one are mostly for device, helping your device to achieve the maximum desired signal to noise ratio that you need for your UE performance.
Yeah, thanks.
So
Jim,
that's what we're doing.
Yeah. Sorry for interrupting, just monitoring the time too. Jim, do you want to essentially talk about this to summarize your experience so far with the, every ecosystem, dealing with the ecosystem, the funding models, the customers, and just like Reza had to pivot from being a chip provider into understanding, there is an interesting aspect of building relays, and then that translated into cloud-based management of relays and so on. What are your unique experiences in this space?
Sure, no, thanks. Yeah, and I grew up in the beginning of the mobile industry with OpenWave and connection management company, Smith Micro, where we serve pretty much all the operators in the world. So very familiar with that. The biggest challenge with them, as everybody who's dealt with them, is how slow their process is, right? And one of the challenges is that we are, like Reza talked about, is very disruptive. So our proposition is, we go to the meetings, we get invited to the C-level and talk about 5G feature, 5G and 5G business models. And our proposition is like, well, you don't have to spend tens of billions of dollars to build out that network. We can reduce your current loads by 30% just in software, with no changes to any of your RAN network, no device changes. And it's like, how can you do this? And you go to the discussion, and you literally see the sides of the group, the product side, the marketing side, support this, but the network side is, is challenged because they're essentially tasked to build out more capacity. So we obviously have, be able to break through and work with that on numerous trials of the technology and prove out that out. And fortunately, we were selected last year. It was a challenge with COVID, but we were asked to be a member of the Facebook telecom infrastructure project, and then asked to join one of their startup competitions for commercialization. And were selected by Deutsche Telekom, and they pivoted us. So they were saying no operator is going to make money on 5G on the handset, and that's where we pivoted to home convergence. So being able to run on a home gateway where they can charge an extra $5, $10, $15 a month for that. Essentially, even with high-speed networks, you still have problems with congestions. So that's been very, very a big initiative, because you see what's going on with the growth for them is in fixed wireless access, and it's much easier for them to start out as a secondary source as opposed to directly replacing the primary fixed line source, because that's more radical for the end user, but to supplement that. And so we've been working with them and actually UCSD and Facebook and Dish Wireless and Intel and a bunch of others to do some proof of concepts for extending this type of private network, as Ketan had talked about, and testing some of these convergent technology to get that out. So what I found out, the faster we can run and get something out in the market, the operators will either embrace or chase. And we're also seeing another forcing function that's going on is with decentralization or neutral host networks, which are building alternative capacities, which essentially could co-opt the large carriers and essentially create disruptions like we've seen in social messaging and the app market in general. So it's an opportunity to either embrace it or have to deal with it. And one of the little sides I'll say is that, one of the jokes I said to the operator is how vulnerable their business model is, and COVID proved it. So I said, you are familiar with what the auto insurance industry did with COVID when people weren't driving around and incurring, risk type of thing. They gave back, I think it was around $14 billion in the US market. And I said, how much have you given back? Because how's your data usage? Because, let's say half your users are unlimited and they're using on average less than 10% of their plan. It's like, give back. Why would we do that? I go, weren't you worried about backlash? And at the time it was when GameStop was kind of being chased with the hedge funds. I said, aren't you worried about just one tweet from Elon Musk saying, shut off your Wi-Fi and run speed tests and crash your towers? Their face turned white. I said, well, you got to embrace all heterogeneous technology, whether it's CBRS or it's going to be Wi-Fi, and leverage that. So we're getting some traction there, primarily from the ecosystem that wants to accelerate the decisions process for the carriers, and then some, especially TIP and Facebook, introducing us to kind of leading advanced operators who see kind of the handwriting on the wall of how plethora of other access technologies come available. So embracing those as opposed to competing it. And from an IP point of view, I'm only like 990 patents behind Reza, so I'll catch up with you next year. But ours is very unique. Most of the stuff, if we're defending something that came across today, is at the layer 4, multipath layer there, or requires layer 2 type of stuff. So we're at layer 3, layer 7, which requires no OS changes and very fast to deploy. And there's nothing out there that was there at the time. There's some people coming in, but we're well defended from the work we've done there. So that's kind of how we see it and how we see how it goes across. I think the more there's venues like this, the more we can get things out in the field, stuff that's Ketan doing, stuff that's Reza doing, the more we get that out there, I think we can actually accelerate those activities. Carriers it's interesting that the struggle that I think they're almost like the underdog, because if they can't move it beyond commoditization, we saw it in voice, we saw it in text, it's happening in data. In France, it's $5 for unlimited plan. It's going to be 5 or 10 unlimited in US. How are they going to make money? So they need new ideas, new type of technologies. So that's kind of our story.
So, Sirish, I'm going to twist this question a little bit for you. I suspect distributed cloud services should be like, all the VCs will be salivating over that funding model shouldn't be an issue. I would suspect, I could be wrong, but that's my suspicion. However, I'm just curious as to why you went after the 5G. What is in it for you for 5G, with regards to 5G? Why is 5G important to you? Can you talk about the connection between distributed cloud services and 5G and your traction there? Or you're being pulled, or you're trying to push?
I think especially on this panel, but also maybe in your entire session, this entire event, Nambi, I'm going to be the least educated person about 5G that happens to be at this event, right? So because my background, I'm a one-trick pony. I spent, nearly 15 years in engineering at VMware, where we were basically building the virtualization ecosystem, selling to enterprises, and telco happened to be a small customer base, a small portion of our customer base. And at Platform 9, for the first 4 or 5 years, we didn't look at 5G. I mean, 5G didn't exist, but we had some of our competitors were making significant traction, I think, in the 4G space. And every time we looked at that and said, no, we're not going there, we're not going there, we're not going there, right? But so we're maybe the exception in that we've actually, maybe adapted our strategy to pivot to the networking operators as opposed to, going away from them. And the reason for that is as we continue to grow and we got past maybe the first 50 customers, one of the things that became very clear to us is that our solution appeals to people who need the cloud experience, but the moment they have distributed infrastructure, the value of a solution goes up even more. And a lot of enterprises are actually looking to shut down their data centers and shut down their infrastructure and move to the public cloud. And the network operators are interesting, right? Because of the nature of physics, because of the nature of the product that they offer, they inherently cannot offer it from a centralized cloud. They cannot, their IT workloads are like enterprise workloads, and some of that is actually moved to the cloud. But the network itself is not something you can just move to the cloud and operate out of the cloud. It's inherently a distributed entity. So that is really where the appeal for us came in, saying, here's a market where, it's a difficult market. It's a long sales cycle, slow to move, slow to adapt, but they really need us. And so after years of staying away, eventually we got pulled into enough conversations. We were like, well, I mean, there's people knocking on our door and asking us to help them. But we were very careful in terms of how we decided to do this. Our approach has been one of partnerships with leading providers of 5G core, with leading providers of 5G radio. We have, for example, a very successful partnership with Mavenir, who's a major supplier in the core and radio. So Mavenir and Platform 9 have worked together to create what we call the Mavenir web scale platform. And we have some very large customers that are now deploying that at scale in production. And we wouldn't have maybe been able to enter this market without a partner like Mavenir, who's we are riding on their shoulders, so to speak, right? Because we're doing this together. So it was really a combination of seeing a need that our technology and our value was well suited for, and then also finding like a route into that market where we were able to go to the market together with like strong partners, as opposed to try to build an entire telco-centric go-to-market, which we did not want to do.
Very nice. Ketan, similar questions to you. Why did you, go after the space? What opportunities did you see? And, what about the funding models and the ecosystem, the traction? So can you comment on those? Can't hear you, Ketan. You're muted.
Sorry about that. One of these days we'll be all face-to-face and not have to remind people to go off mute. So Geoverse was founded in 2018. And our thesis was, the commercial thesis for existence, besides everybody knowing that indoor coverage is poor in most buildings, or at least certain parts of buildings, was the fact that all the carriers say they want to provide indoor service. But I was at a very large carrier for many years. And what happens is you look at capital allocation and capital budgets, and invariably you'd run out of funds somewhere around the Fortune 100 that you would want to prosecute and build indoor coverage on, right? Sometimes we Fortune 75 companies we can go focus on, sometimes we Fortune 150, but it never went much below that. And there's a complete middle price there between, Fortune 100 and Fortune 1000 that is underserved, Think about buildings that are less than 500,000 square feet, that is too small for the tier ones. And so we figured that if we went after that middle price, which is one that the carriers can't scale to, and one that we can solve the indoor coverage problem through our business model, then we would be able to create enough value and have a very nice exit 5, 7, 8 years down the road, basically. Right? That was the core thinking, right? When you do a startup, you want to think about where you start, and you must at least have a thesis for your exit. And then if you pivot, then, as you pivot, you have to think about how you're going to exit that business, right? That's what creates for successful exits. So once we established the foundation of our business model, which was we will provide a complete managed service to the building operator. So if UCSD said that, hey, can you come and build us a indoor wireless network that's only to be used by the university employees and students, we can come in and we will completely finance that entire design and deployment and operations of the network on a monthly payment plan over a 3, 5, or 7 year period, right? So there's no CapEx that comes out of your pocket. Of course, there is an OpEx cost to it, but then we've bundled everything in such a fashion that your net cost will be lower than paying one of the tier ones what you would have to pay, using a Geoverse SIM card and Geoverse cellular service when you're on campus. So that's kind of the fundamental thesis, right? So the funding of building out this indoor coverage, which is what prevents a lot of buildings from having indoor coverage, is really what we solve through how we're deploying a managed service, right? So that's turning the business model a little bit. Now we have free spectrum solved. We've solved the business model problem. And then the third thing is, the third thing that enables us to scale and deploy this at a much lower cost than the traditional operators was the fact that besides, everybody uses LTE data today and will go to 5G data soon, right? Or is already using 5G data. But packetized voice over LTE is what all the operators now have deployed, and they know how to manage it and hand over. So what we could do is we could actually deploy, 3-rack units inside the enterprise firewall on the edge and have a complete switching system using, the EPC and the mobility management entity and some of those elements. And what that did was, reduce the cost, right? We don't need to have expensive switching centers like the old days. We don't have to pay for real estate. All we need is about 3-rack units in your IT closet, and we can switch an entire UCSD of that, essentially. So we've completely disintermediated the cost structure. We don't have expensive distributed antenna systems in there. We use a single CBRS radio, and we'll have the 3 carriers kind of connect into our neutral host solution if they choose to use the indoor network. So that neutral host part is also kind of taken care of with what we're doing. So we've completely disintermediated the whole value chain and created value, right? So that's kind of how we think about ourselves, and we have a startup in the wireless carrier space, right? After a very long time. Now, when it comes to funding, this is not if you go to Sandhill Road VCs, they have a very different mindset of the kind of companies they invest, and they turn their funds every 7 years or so. So they're looking at an exit 3 to 5 years, preferably, because they know things get delayed, right? Ours is a little longer in terms of a runway because it takes time to kind of get the enterprise customers and deploy it, and we want those 5-year contracts, and we want to build them up so we can have a nice exit. We also needed roaming, and we also needed we knew that we had to interconnect all these private islands, right? You're not going to use a Geoverse SIM card when you step out the building, you can't use the network, right? So we needed roaming relationships. And so we found an investor in a company called ATN International. And they're a kind of a patient hedge fund, essentially. And they have a whole set of assets. Like they are the main cellular operator and fixed line operator in a lot of the Caribbean islands. They just acquired Alaska Communications. And so they have a whole portfolio of telecom assets. And they understand this business. And so we went and got our initial capital from them. And that's really what's allowed us to build the platform out, work it, it's fully 3GPP compliant, and also have the roaming relationships. And, so that was our focus. Our focus was a lot on buildings and multiple dwelling units. So talking about pivoting, right? When COVID hit, we had to pivot, right? Our pivot was slightly different because of the kind of product we offer. I had to pivot from a segment to education, right? So because of COVID, there was a ton of money that the government made available through the CARES Act and, funding the schooling system for a large number of counties across the country. And so we were able to pivot away from, we couldn't go talk to commercial real estate folks when no one was going into offices. But through the CARES Act, we were able to solve the digital divide problem. And we actually have deployed a commercial network that is operational today in the city of Tucson. And it was focused on providing connectivity for the schools around there and for children who lived in underserved communities. But the thought was that longer term, the city services would also use that network, right? And so that was the pivot for us a little bit through the COVID days. And then we've got additional school districts that have been deployed in Florida and Pennsylvania. So we pivoted a little bit. And luckily now that, COVID seems to be on the decline here, and people are starting to think about coming back to work, the commercial real estate segment has come back to us. So that's a little bit on the pivot for us and how we adapted through COVID.
Thanks, Ketan.
Nambi.
We're running out of time, so I just want to, throw the floor, open to folks here if they have any questions to the panel. Anyone on the Q&A chat? Because we're running out of time. So that's why I said any questions from the floor. Looks like we are. Anyone have questions here? Do we have any questions on the chat? I didn't see. Oh, there's a question there.
Yeah, I have a question on IP protection. How much of what you do is you're protecting with patents, and how much is, let's say, you're doing trade secrets? Is there a trade-off between the two? Sometimes if you publish the patent, people see it, and then it can secretly end up in someone else's IC, and you don't know it, or maybe you keep it as a trade secret. What is your trade-off? You see a trade-off there?
You're asking who? We file a lot of patents. So patents are system level, are key, and so the patent that you can actually clearly define as a system that you can actually protect the the way you're doing it is valuable. The one that goes detail in circuitry, a lot of time we actually go like a trade secret, because many of the like low-level circuitry, people can find other ways to do it. So we try not to educate what we're trying to solve. If you make a pattern, then you explain what the issue was and how you're solving it. So the areas that we think is become specific, and then if you file a patent, is more like educating other people about the know-how. So we try to do those more like a trade secret, but on the higher level and levels that you is a key elements, and there are not many ways to do it, then we file patent, and that's what we have been doing a lot, especially on the circuitry. If there's something specific that is the only way to do it, then we also file a patent on that area. Sure.
Any other questions? Okay, if not, let's thank the panelists and for a very nice, informative session. Thank you. Thank you all.